This is Mathematics Form 4, and then we're going to discuss Chapter 3, Logical Reasoning. Subtopic is 3.1, A, B, C, and D. Chapter 3, Logical Reasoning. Subtopic 3.1, Statements. Okay, the learning standard for today is explain the meaning of a statement and hence determine the truth value of a statement. What does a statement mean and how do you determine the truth value of a statement? A statement is a sentence of which the truth value can be determined. That is either true or false, but not both. Now we look at the example. Determine whether each sentence below is a statement or not a statement. Justify your answer. Now we look at question A. Please send the workbook. Okay, if you see this sentence, if I say, please send the workbook, we cannot say this sentence is true. We cannot say this sentence is false also. So that means the truth value cannot be determined. So this sentence is not a statement. So you will write the answer like this, not a statement because the truth value cannot be determined. Now we look at B. Kuala Lumpur Tower is the tallest tower in Malaysia. Okay, this one is a statement because we know that is true. Okay, so a statement because it is true. Now we look at question C. How do you come to school? Okay, for this sentence, we cannot say this one is true. We cannot say this sentence is false also. So this one, your answer should be not a statement because the truth value cannot be determined. Now we look at question D. X plus 3 equal to 5. Okay, this one also not a statement because the truth value cannot be determined. Okay, how I say like this? Because we look at X unknown there. X can be any number. X can be 0, can be 1, can be 2, 3, and so on. So that means X plus 3, we have a lot of answers. We don't have any true or false answer. So this one not a statement because the truth value cannot be determined. Okay, now we look at E. Negative 6 is less than negative 8. Okay, this one is a statement because it is false. We look at example 2. Determine whether the following statements are true or false. Prove it. For A, okay, bracket x plus y, close bracket, power of 2 equal to x squared plus 2xy minus y squared. X is not equal to 0, y is not equal to 0. Okay, how do we know the statement on the left hand side whether it's equal to the statement on the right hand side or not? So we can substitute the number inside. You can choose any number. You can choose beside number 2 and number 3. Okay, I choose 2 and 3. Okay, so you look at here first. This one, x substitute 2 inside and then y substitute 3 inside. 2 plus 3, 5. 5 square, you get 25, right? And then this one, another statement. This one is the statement on the right hand side. Okay, so this one substitute 2 and 3 inside x and y, and then the result is 7. So you look at here, the left hand side statement we get 25 and then the right hand side we get 7. That means the statement on the left hand side is not equal to the statement on the right hand side. So the statement, this one is false. Okay. Now we look at B. X, this one, bracket, open bracket first. X plus y, cross bracket, okay, power of 2 is less than 0. And then X is the element of R. Okay. This one is false. Okay. You look at here. This one also same. You can substitute any number inside. Okay. Let's say I choose 1 and 2. I choose 1 and 2. Okay. So 1 plus 2, 3. 3 square, we get 9, right? Okay. 9 is greater than 0. So this statement still false. And then now we look at C. 2 plus 6 times 4, we get 26. And then this one is 4 plus 6 times 2. This one we get 16. So 26 is greater than 16. So this one is true. This statement is true, okay? And then we look at D. 2 is an element of factors of 8. Okay, this one still true. Why? Because 8 can divide exactly by 2. So this one is true. Now we look at E. Element 2, 5, and 7 is union to prime numbers and equal to 2, 5, and 7. Okay, this one is false. This one is false, okay? What is the true statement? Okay. The true statement should be right like this, right inside this. Because 2, 5, 7, 2, 3, 5, 7, this one, all of these are prime numbers. So you must write equal to prime numbers, blah, 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 like this, okay? Okay, this slide is the self-practice 3.1a. So you can do the practice yourself about the statement, not a statement, and then true, false of a statement, okay? The learning standard for today is negate a statement. How do you negate a statement? We use the word no or not to negate a statement. The negation of the statement P is written as title P. Okay, this one we read title P, okay? Now we look at the example. Form a negation for each of the following statements by using the word no or not. Okay, we look at A. 12 is a multiple of 5. Okay, when you form a negation statement, you have to write like this. 12 is not a multiple of 5. Now we look at B. 41 is a prime number. form a negation. Okay, for the negation statement, 41 is not a prime number. We look at C. All multiples of 5 are multiples of 10. For the negation statement, we can write like this. Not all multiples of 5 are multiples of 10. Now we look at D. 0.4 m is equal to 400 millimeters. So for the negation, 0.4 m is not equal to 400 millimeters. So this one is the self-practice for the negation. The learning standard number 3 is determine the truth value of a compound statement. How do you determine the truth value of a compound statement? A compound statement is a combination of two or more statements by using the word and or. We look at example 5. Combine the following statements P and Q by using the word one and two or. Now we look at question A. For statement P, the statement is a pentagon has two diagonals. For statement Q, a heptagon has four diagonals. So how do you combine these two statements becomes a compound statement? If you use words and, you can combine like this. A pentagon has two diagonals and a heptagon has four diagonals. Okay, now we look at 2. If you use word or, you can combine like this. A pentagon has two diagonals or a heptagon has four diagonals. Now we look at question B. Statement P, a pyramid has 5 planes. Statement Q, a pyramid has 5 vertices. So if you use word and to combine these two statements, you can combine like this. A pyramid has 5 planes and 5 vertices. If you use word or, you can combine like this. A pyramid has 5 planes or 5 vertices. Now we look at question C. Statement P, -4 is an integer. Statement Q, 2 is an integer. So if you combine these two statements by using the word and, you can combine like this. -4 and 2 are integers. If you use word or, you can combine like this. Now we look at example 6. Determine the two statements P and Q in the following compound statements. Okay, if I give you a compound statement, how do you write the compound statement into two statements? So we cancel the word and, So the first statement for P should be P plus 5 plus 3 is greater than 5. And then statement Q should be this one, the second statement. 5 minus 3 is less than 5. So we look at example B. The compound statement is 9 and 91 are prime numbers. So for your first statement P, you should write like this. 9 is a prime number. And then statement Q, you can write like this. 91 is a prime number. Now we look at question C. This one also same. You cancel the word or. No need write the word or. So you spread these two statements. The first statement P, you should write 2 square equal to 4. And then statement Q, you should write 2 cube equal to 8. Now we look at this one also same. You cancel word or, no need write word or. So your statement P should be right. Negative 9 is less than 10. And statement Q, you should write. Okay, this one, we look at this table first. The truth value of a compound statement can be concluded as shown in the truth table below. We look at here. Of course, we have two statements. Statement P, statement Q, okay? So here we have P and Q, P or Q. So we look at this table first. We go through this table first. Okay, if P true, Q true, that means if both are true, P and Q both are true, if we combine the statement P and Q, this one's still true. If we combine P or Q, this one's still true, okay? But, okay, if P is true, Q is false, if we combine the statement P and Q, so this one is false. Because if we use and, must both true only true. If one of the statement is false, that means P and Q is false. But if we combine the statement by using P or Q, the statement still true. One true, that means still true for P or Q, okay? The third one also same. If P false, Q true, if we use P and Q, we combine it with by using words and P and Q. This one, the compound statement is false. If we use P or Q, this one is true. And then the last one, if P false, Q false, of course, when we combine the statement P and Q or P or Q, if both already false, that means the compound statement already false, okay? Now we look at the example. Determine the truth values of the following compound statements. Okay, we go through one by one, okay? So, I use the almost similar example, okay? 2 plus 3 equal to 5, or 2 times 3 equal to 6. Okay, you look at the first statement, 2 plus 3 equal to 5, this one is true. 2 times 3 equal to 6, also true. If both statements are true, if we use or, that means true, okay? How about the second example? Second example, we use and, right? So, we determine the first sentence, this one is true. And then second sentence, statement still true. So, both true. That means when we use and, the compound statement still true, okay? We look at the third example. 2 plus 3 equal to 5, this one true. 2 times 3 equal to 23. Of course, this one is false, right? But because we use or, if one is true, that means if you combine these two statements with or, the compound statement still true. And then we look at example number 4. 2 plus 3 equal to 5. Okay, this one of course true. And 2 times 3 equal to 25. This one is false, right? So if you combine the statement by using the word and, of course the compound statement is false because one of the statement is false. Now we look at example number 5. April and May has 30 days. Okay, April has 30 days. This one is true. May has 30 days. This one is false. But because I use word and if one false, that means the compound statement is false. Okay. And then the last example, April or May has 31 days. So the first one, April has 31 days. Of course, this one is false. And then May has 31 days. This one is true. Because we use the word or, so when we combine these two statements, you can try to do this self-practice 3.1c about the compound statement and then the truth values for the compound statement. Okay, the last learning standard for today is construct statement in the form of implication. 1. If P, then Q. P if and only if Q. Now we look at the statement involving implication. How do you construct a statement in the form of an implication? Okay, implication if P then Q. A statement if P then Q is known as an implication where P is denoted as the antecedent and then Q is denoted as the consequent. Okay, we look at the example first. Example 8. Form an implication if P then Q with the given antecedent and consequent. So we look at question A. If I give you antecedent is K is divisible by 5, consequent is K is a multiple of 5. So how do you combine the antecedent and consequent to form an implication? You can combine like this. So you look at the learning standard here. If P then P. Okay, so you can combine like this. If K is divisible by 5, the first one, you write this one, you copy down the antecedent first. If you copy down antecedent first, if K is divisible by 5, okay, comma, then you copy down the consequent here. Then K is a multiple of 5. This one very simple, okay? Now we look at B. Okay, combine the antecedent and consequent. So you write down the antecedent first, but start with if. If set K is a subset of set L, comma, then the number of elements in set K is less than or equal to the element in set L. Okay, now we look at example 9. This one is determine the antecedent and consequent for the following implication. If P, then P. Okay, this one is I give you an implication. After that, you have to write down antecedent and consequent. Okay, now we look at A. So I give you an implication right here. If X is a factor of 16, comma, then X is a factor of 64. So how do you write down the antecedent? So for this statement, for the first statement, we write the first statement is antecedent. X is a factor of 16. This one is antecedent, okay? And then for consequent is S is a factor of 64. Now we look at B. For the implication, if X minus Y is greater than 0, comma, then X is greater than Y. So for the antecedent, you write the first one, the first statement here, antecedent. X minus Y is greater than 0. This one is your antecedent. For consequent, you write X is greater than Y. For self-practice 3.1d, question number 1 and 2, this one is ask you form the implication by using antecedent and consequent. And then question number 2 is if they give you an implication, you have to write down the consequent, antecedent and consequent. Okay, I think this one no problem for you. Okay. An implication P if and only if Q consists of the two following implications. If P, then Q. If Q, then P. Now we look at the example 10. Form an implication P if and only if Q with the following implications. Okay, we look at here. This one, question A. The first implication, you look at this part. If P, then Q. Okay, the first one is if P, then Q. The format is if P, then Q. If K is a prime number, okay, K is a prime number, that means this one is statement P, okay? Then K has only two factors, then Q. So K has only two factors is statement Q. And then for implication 2, they write Q first, if Q, then P. So if K has only two factors, comma, then K is a prime number. So how do you combine these two implications? You look at the notes here. These two implications and then combine becomes P if and only if Q. This one very simple. So you just copy down the statement P first. Okay, statement P is this one. K is a prime number. So you write K is a prime number and then if and only if in the middle here, right? Then the format is P if and only if Q. So I write the sentence like this. K is a prime number if and only if K has only two factors. Okay. So we look at second example. This one also same. You write P first. After that, you write the format P if and only if Q. Okay. So the first implication is in format if P then Q, and then second implication is in format if Q then P. Okay. So I write the statement P first. Y equal to ax power of n plus b is a linear equation if and only if n equal to 1. For example 11, write two implications based on the implication P if and only if Q given. So we look at another example. This one is in format P if and only if Q. Okay. So how do you write in two implications? So the first implication, the format is if P then Q. So you write the answer. If square root of r equal to 15, comma, then r equal to 225. Okay. For second implication, you write Q first. Okay. If r equal to 225, comma, then square root of r equal to 15. Now we look at another example, also same. They give you the implication is in format P if and only if Q. So x less than 6 is P, if and only if x plus 10 less than 16. This one, x plus 10 less than 16 is Q. So how do you write the implication 1? Implication 1, the format is if P then Q. Implication 2, the format is if Q then P. Okay, so you write like this. If x is less than 6, comma, then x plus 10 is less than 16. So for second implication, we write Q first. Okay, if x plus 10 is less than 16, comma, then x. This one is the skill practice for implication. Okay, in the format P if and only if Q, and then number 4 is you have to write down two implications if I give you the format P if and only if Q. Okay, so you can do your